Now we're going to use the t-distribution to do things very similar to what we did with the normal curve, which is finding t-scores, similar to z-scores, and finding the area under the t-distribution. You'll notice that the t-distribution looks essentially like a normal curve. Just remember that there are multiple versions of it, and typically there's going to be more area over in the tails. The tails will be a little bit fatter, and the top is going to have a slightly shorter peak. So that's the primary difference. More area in the tails, peak is slightly shorter. So let's imagine that we have a sample of puppies. Let's say they're all about the same age and same breed, and the average is 20 pounds. So X bar is 20 pounds. It says here SX, the standard deviation is 5, and they got this average by taking the data from 12 different puppies. So they sampled 12 puppies and they found an average of 20 pounds and a standard deviation of 5. So let's try to figure out what the t-score of a 13-pound puppy would be. Well, we always like to sketch out our normal curve. So let's go ahead and put 20 in the center, because that's our mean. And even though it's x bar instead of mu, it still goes in the center. Standard deviation of 5, it's s instead of sigma, but same idea. We're going to add 5, in the other direction, subtract 5, subtract 5. So now we have our roughly normal curve sketched out. And we have these marked on here, and we want to find a 13-pound puppy. So what's the t-score going to be? Well, let's mark our 13 pounds on here. So somewhere down here. So it's clearly below the mean. It's more than 1 standard deviation, but less than 2. So somewhere between -1 and -2 is going to be our t-score, because it's how many standard deviations it is from the mean. So just like we did with the normal curve, we're going to use our formula to calculate this. We have 13 as the value of x, the value we're looking for. Our mean is 20, that's x bar, and then s, our standard deviation, is 5. Formula is going to be exactly the same thing it was for calculating z-scores, except we substituted in the new names. So instead of having mu here, we have x bar, but both stand for the mean. Instead of having sigma down here, we have s, but again, both stand for the standard deviation. And instead of having z over here, we have t, because it's the t-distribution instead of the z. X stays the same. So everything gets a new name, a new look, but it's really the same thing underneath. So now we just need to pop in these values. Value we care about is 13. Let's switch pens here. 13. Our mean is 20, so we subtract 20. And then we divide that all by our standard deviation of 5. So we get -7 over 5, which is going to be -1.4. So our t-score is -1.4. Again, like normal curves, when you have z-scores, you can work backwards. If you're given a t-score, you could always work back to a value by multiplying it by the standard deviation and adding the mean to get back to an x value. So if that ever comes up, same general approach. Now let's go ahead and answer a new question. What proportion of puppies are likely under 13 pounds? Well, if we mark our 13 pounds on here again, somewhere roughly around there, this time we want to find the area under the curve. What proportion are under 13 pounds? So we want to find the area in this part right here. So in order to do that, we're going to take the same approach we did before, but we're going to have to add a little bit of extra work, because this time we care about things like sample size. So our sample size was 12. That's how many puppies were in this sample, how many puppies had data collected on them. In order to use the t-curve, because remember it's got multiple different variations that depend on sample size, we need to calculate something called degrees of freedom. Now, it's a little bit weird, a little bit patriotic maybe, but degrees of freedom is just the sample size minus 1. Comes up a lot in some of the nitty-gritty of statistics, so you'll see it around here and there. But just know, degrees of freedom, it sounds maybe complicated, but it's just how many people in your sample minus 1. So in this case, we had 12 puppies in our sample, we subtract 1. Our degrees of freedom for this problem is 11. That's all there is to it. So now, we have 11 degrees of freedom, We still know all these other values are the same, and we want to find the area under the curve where t is less than that negative 1.4, because before we already converted 13 pounds into a t-score, and we got negative 1.4. So we're going to go ahead and use that negative 1.4. I'll sketch it in one more time. And we want to find the area under that part of the curve. So now let's go ahead and pull out the TI 83 or 84. To do the actual calculation, we're going to go to second dister, the same way we did our normal CDF. And instead of going down to 2 for normal CDF, we're going to go down all the way to 6, T CDF. So T CDF number 6 is the one we want now. The values it wants is, again, very similar to normal CDF. The left t-score, which in this case, because it goes all the way down to negative infinity, is going to be negative some big number. So let's say negative 1,000. And because we stop on the right side at negative 1.4, we're just going to type in negative 1.4. But there is one more number we have to type in, and that's the number of degrees of freedom. So we're going to also add 11 at the end. Close our parenthesis, hit enter, and that's going to be our answer. So very, very, very similar. The only thing you have to remember to do that's new is type in your degrees of freedom at the end. Again, finding it is a t-score, very similar to finding a z-score. And then finding the area, use t CDF.